There are a few things that are important to note about the geometric series. Note the formula that we use to define the geometric series starts summing at n equals 0, not n equals 1. And also the r value must be constant with respect to n. It can't change when n changes or depend on n. Let's do some quick examples of this. If I had the sum n equals 0 to infinity of n over 7 to the n, that's something to the n. Can we say that the something to the n is r to the n, so r would be equal to n over 7? Well, that's going to change when n changes, so r would not be constant, so we could not call that a geometric series. So that's an example of that issue. Let's talk about this one real quick. What if you have something that doesn't start at n equals 0 and you still want to use that 1 over r 1 minus r formula? What if you have something like the sum of, let's say n equals 1 to infinity. We had a half before, let's use that. So this is not starting at n equals 0, right? So we want it to be the sum n equals 0 to infinity, so we can use the formula 1 over 1 minus r. Well, what we can say is the sum n equals 0 to infinity is really just that first term, which is r to the 0, plus the sum n equals 1 to infinity. Right? We can say this starts out with n equals 0, which would be r to the 0, and then n equals 1, which is r to the 1. And so we could kind of split that first term out. Then we can say this equals 1 over 1 minus r. Is that always true? Well, it's only true if the absolute value of r is less than 1. So if you have this, you can say, well, I know what this is equal to, and then you can subtract this from that to get that. So just kind of moving this over there. So that's a way to handle if the sum doesn't start at 0, it starts at 1. You can kind of add on that 0 term, then you know what that whole thing is, and then subtract it off later. Let's take another kind of big picture look at the geometric series. So let's write the geometric series, n equals 0 to infinity r to the n. Which formula from the continuous world is this like? So we'll say option A would be the integral 0 to infinity x to the n, x to the p dx, or you could say the integral x to the negative p dx, or option B would be the integral 0 to infinity something like e to the x dx, or integral e to the negative x dx. Which one of these two options is more like this one? Well, here the base is constant and the power keeps changing. So we could say the power is changing or a variable. So which of these options, A or B, has the base constant and the power changing? It's B, because e is a constant. Here the x starts at 0 and then goes to 0.00 something and then a little bit more than that, so there the base is changing. So geometric series is really like integrating e to the x or e to the negative x or 0.5 to the x or something like that. So this one is a nope. So that's partly why the geometric series is so important. It's like exponential decay, basically, which is really important in the continuous world.